A trough of water is 8 meters long, and its ends are in the shape of isosceles triangles whose width is 5 meters and height is 2 meters. If water is being pumped in at a constant rate of 6 cubic meters per second, at what rate is the height of the water changing when the water has a height of 120 centimeters? So what we know is that the water trough is 8 meters long. We know that it's an isosceles triangle, and the width of the isosceles triangle and the trough is 5 meters, and the height is going to be 2 meters. Those are the static measurements. The constant rate here is given as 6 cubic meters per second. That is going to be our dV dt. That's the change in volume over related to time. What we're looking for is the rate of the height and how that's changing. So that'll be dH dt, and we want to find that change in height the instant the height of the water reaches 120 centimeters. So let's begin by drawing a picture. Our picture is going to really represent an inverted triangular prism. The ends are going to be isosceles triangles. You're given your width, length, and height at 2, 8, and 5. And this blue line right here represents the water level rising, and the height, or the H right here, is the height. So you got the width and the height of the water. What we're given is our dV dt, 6 cubic meters per second. What we want to find is dH dt when H is equal to 120 centimeters. Don't forget that we're going to use we're going to convert 120 centimeters to 1.2 meters to keep our units all the same. And we know that because up here we're given our volume in terms of cubic meters. Okay, let's start by setting up our equation. Okay, so the volume of a triangular prism is 1/2 the length times width times height. We're given that the length is 8. We're going to use similar triangles to express W in terms of H. Okay, so we can kind of get all one big formula. So I don't have room to write it, but I'll kind of highlight it here. The similar triangle I'm going to use is here. This has a width of 5 and a height of 2. So this proportion is going to be 5/2. The water, the smaller triangle, is going to be W/H. Okay, so if you want to write that out, not right there, got W/H. So if you want to write that out, it would be 5/2 equals W/H. And when you solve for W, you're going to get 5/2H. And that's what shows up right here. Okay. This 4H comes from 1/2 of 8. So that's going to be 1/2 H. And when we simplify everything, we have V is equal to 10H squared. That's going to be the formula we're going to differentiate. So to find dV dt, that's going to be 20H dH dt. And now we begin to substitute our known values. We know that dV dt is equal to 6. We know that we want to know the height changing at 1.2 meters per second. dH dt is what we're looking for. So when I solve for dH dt, we're going to find out that height is changing at 0.25 meters per second. Remember to write your answer as a complete sentence. So the height of the water is rising at a rate of 0.25 meters per second when the water is 120 centimeters high. Our correct answer is C.